Good afternoon, everybody. My name is Dale Brosius. I'm the Chief Commercialization Officer for IACMI, and welcome to Innovation Insights for September 2024. I don't know about the weather where all of you are tuning in from, but on Saturday it was 91 degrees in Indianapolis, and fall came and it's 20 degrees cooler today. So it's a kind of a nice respite from the hot weather we've been having here, but looking forward to a productive fall. We've had a pretty busy fall already. First week of September, IACMI and a lot of our industry colleagues were at the SPE ACCE conference in Detroit, and then a week later we were all at CAMEX in San Diego. So again, quite the busy start to the fall season already. Just a couple of quick slides to open up here, just to remind IACMI about our offering to our members, built around the themes of convene, connect, and catalyze, bringing folks together and making things happen, with a lot of co-funded projects, training interns. We have a new intern program that we introduced at our members meeting that kicks off start to 2025, and I hope our members take advantage of that, providing consulting, our great working groups that we have, and other activities. So if you're not an IACMI member and you're on this call, it's really easy to join. You go to iacmi.org members, fill out a request form there. We'll get back to you and move the process through. So just a reminder that we are recording this, and all of our previous webinars are on the IACMI website. So, if for some reason there was an earlier episode that you missed and you want to go cop back on, you can. Or if you see something here that you think a colleague would be interested in, that this episode will be up by the end of the week, and you'll be able to forward that on to them to take a look at. They're also on our YouTube channel as well. But since we started this in May 2021, we've had over 33 episodes and over 90 members and partners featured. We've got 3 more scheduled for this year after this one. Again, once per month, Monday, October 21st, we've got Agile Ultrasonics, Vitiform 3D, and Professor Dakar Penamadu from the University of Tennessee, Knoxville, lined up for that. So if you'll join us for that, Kim will put into the chat the link to go register for that one if you're ready to go do that today. And then we'll follow that with one on Monday, November 18th, and then December 16th before it heads off for Christmas. And then we'll resume again in January. So today we've got 3 great presentations lined up. Concordia engineered fibers. I like to look at this as, commingled materials have been around for a couple of decades, but these aren't your grandfather's commingled that Sean's going to tell us about. Some amazing things, especially in the era of sustainability that Concordia is working on. Dr. Uday Vaidya, who's our Chief Technology Officer at IACMI, and a couple of colleagues from Georgia Tech and Open University are going to enlighten you about an IUCRC Industry University Cooperative Research Center that's been in effect now for about 3 years, and expanding on composite hybrid material interfacing. And then we'll wrap up with Scott Francis, the editor-in-chief of Composites World. Second week of October will be the Composites World Carbon Fiber Conference in Charleston, and Scott's going to give us a preview of what's going to happen there, and hopefully all of you will join us. So with that, I'm ready to hand it over to Sean Reymond. Sean's the Chief Executive Officer for Concordia. So if you are ready to share.
Very good. Thanks, Dale.
Okay. I'm trying to. Are you able to take over, Sean?
Yeah, should be.
Yes.
Yep. Sounds like we got it. Just need to put it in slideshow mode.
Okay, there we go. Great. Well, thanks, everyone. Thanks for having me here today. And it's a pleasure to speak to the IACMI group. And so for today, I'll be talking about thermoplastic commingled products. And to start off with, I want to give everyone a short overview of what's available in the marketplace from a thermoplastic prepreg perspective. So to start off with, there's commingled fiber, and it's typically a fiber-based material. and it's available in the marketplace from Concordia with different sizings on it. Then we get into things like unidirectional tapes that are typically fully consolidated and get used in a laminating type process. Fibers are very, very aligned and debulked. Then we get into organo sheets, where it's essentially taken some thermoplastic prepreg and consolidated into fully consolidated sheets that are then used for further molding processes. And then finally, there's chopped fibers. Chopped fibers can come from either recycling or chopping organo sheets or tapes, or just simply long fiber injection molding. So from Concordia Fibers perspective, these are 4 primary categories of thermoplastic composites out there. So and with that, let's talk about our commingling process for thermoplastics. So for those of you who don't know, we started off with a bobbin of thermoplastic fiber and a bobbin of reinforcing fiber. So in this case here, it could be all the thermoplastic fibers mostly look white unless they're pigmented. And this is a bobbin of carbon fiber. And when they're nicely commingled, they will look like the bobbin on the right, where you can see a slight hint that there's something mixed in with the carbon fiber, or sometimes not at all. So Concordia Fibers, our commingled yarn is I sort of joke internally and call us and say that we're on generation 3B. If any of you worked with our fibers more than 4 or 5 years ago, you really need to take a fresh look at us. I used to be a customer of Concordia's 10, 12 years ago for commingled fiber. And, and back then it looked sort of like your grandmother's knitting wool, versus today it looks like a much more sophisticated and organized, aligned toe, like you might expect for a high performance composite. So essentially we build commingled products for both the thermoplastic Towpreg side of things and also for a thermoset traditional molding. So we might blend carbon and Anagra for thermosets, or carbon and different types of glass or what have you. Or traditionally, for what we're talking about here today, is a reinforcing fiber and a thermoplastic fiber. So the real big benefit of commingled fibers is the high drapability. You're going to end up with fiber drapability or fabric drapability as you would with as a textile might be able to provide, whether it's a plain weave or a twill or a harness satin type weave, and you're going to yield the same drapability as opposed to some of the other formats that are already consolidated, like unidirectional tape or organo sheets. Another attribute of our material these days is low bulk. Over the last few years, we've really worked hard to eliminate the bulk. The early generations of commingled fiber, and still some out there in the industry, are very bulky. But Concordia's latest generation of material is low bulk and really focuses on aligning fibers in an optimal situation. And part of our enhancements we've done lately is adding sizing. And so the sizing is there not just to improve the fiber matrix interface, but also to facilitate the use of the fiber or the Towpreg in downstream processes, whether it goes into braiding or pultrusion or tailored fiber placement. They all need different stiffnesses or hands or protection on the fiber. And that's something we customize on an as-needed basis. And all this better protection and fiber alignment lead to better mechanical properties. And typically, most of our carbon fiber is sold as a zero twist of flat tape-like material, sort of like a Toray T700 roving, but not quite that organized. But we also do twisted products. Typically, glass gets twisted, and we also have other specialty variations where we ply it or spread it to do custom builds as needed. And then our latest innovation at Concordia is our semi-consolidated. It's really an exciting product that we've developed here lately, where it bridges the gap between commingled fiber and slit tape toe, and it's much more debulked. It's thinner, and we can adjust the drapability of it. On the stiff side, it could be fairly stiff, like slip tape toe, or we can make it a little bit softer, more closer to commingled fiber. So just some more options for the future. And I feel it's important to talk about the word commingling in the industry. So the word commingled fiber is used to cover a wide range of constructions, and some companies call co-winding or co-twisting or co-weaving commingled fiber, and that's sort of depicted here by these red and black cross sections, and clearly they're just two rovings or yarns put together, versus Concordia fibers. Commingled is depicted on the image on the right, where the larger circles are the thermoplastic fibers and the smaller circles are the reinforcing fibers. So, but the way Concordia does it, you can imagine how the resin only has to travel a few filament diameters to wet out the material, versus having to travel a whole bundle or toe diameter in the other scenarios. So here's a few pictures showing you what Concordia does and also what's available out there in the industry. So looking at the upper left, we have our traditional flat commingled toe. It's a, what you see in the image there has the thermoplastic mixed in with it already. And it's a size product. It's debulked and flat, and it's going to behave much like a traditional roving going into your process, however you're accustomed to using it. Then we have our twisted toe. It's going to make a little bit rounder. We can also control the amount of twists. Some customers like to have the ability to push on a toe for, let's say, for 3D printing applications. And then the third picture across the top is our semi-consolidated. It looks and feels more like a slip tape toe. It's not as the width tolerance isn't as accurate as a slip material, but it's the volume fraction down the length of the toe is very well controlled and works out very well for thinner applications. And then the image on the upper right is just highlighting a commingled step used for thermosets. For in this case, we're blending a negative fiber and carbon fiber to go into tennis rackets. So now, if you compare the images above to the images below, one technology used in the industry is air jet commingling, where you're just using turbulent air and high velocity to intermingle the filaments. And what that does is it makes the fibers wavy. The picture in the bottom middle is showing a coarse spun thermoplastic prepreg toe. So it's very round, it's very tall, and the resin has to flow one toe diameter into the middle to fully wet it out. But it's very consistent. And then lastly, the image on the bottom right shows some other commingled fibers in the industry that are much wavier and less well blended. So just for comparison purposes, to talk about the benefits of sizing, the two images on the left show unsized products, and the images on the right are from sized products. The two braids up above use the same input material. They're both a 12K input. And to me, the first thing that jumps out on the one on the left is the broken filaments. And there's no ruler in the picture, but you can take my word for it that it's about 50% bigger than or bulkier than the braid on the right-hand side. And again, showing you the benefits of sizing, how you can take the unorganized, hard to work with supple fiber in the bottom left and turn it into something that's much more organized and easier to work with. So to revisit some of these attributes I talked about in the pictures, here's some sketches or some close-ups to highlight the differences. So air entangled commingled technology yields for very disrupt wavy fibers that aren't aligned. Concordia's commingling process yields a very parallel, uniform commingling, where the fibers have the opportunity to work together in future composite parts as they get built into something. The pair of pictures in the upper right show benefits or disadvantages of poor fiber matrix interface. So this is a carbon fiber PEI. And you can see in the left picture where the filament's pulled out of the resin, where there's poor interface, and then the image on the right shows very few fibers sticking out. So it's a great interface. These are the types of things that Concordia Fibers looks at to optimize the quality and the attention to detail we put into our commingling. The pictures in the lower left again show the striping in the left picture versus the uniform color in the right picture, and again highlight to how we control the blending of the fibers. And then the table on the lower right shows potential fiber volumes that we can achieve with PA6 or peak or PPS in using a 12K. These are our standard volume fractions. We can make other fiber volumes with some planning as well. And just so everyone has a sense of what material inputs are possible in commingling for thermoplastics, is pretty much any polymer that can be made into monofilament or multi-filament yarn can be used in our commingling process. So this table on the left is organized from mostly hotter temperatures to lower temperatures, but also the temperatures also closely guide us down the level of mechanical properties and temperature resistance. And then on the right, we have a whole selection of reinforcing fibers, and it's pretty much the same reinforcing fibers that are used in thermoset composites from various size standard modulus carbons from 3K to 50K to intermediate modulus, high modulus pitch carbon of various stiffnesses, e-glass, quartz, basalt, flax, hemp, aramid, metal fibers are all things we've included. You know, some things that are interesting on this list here, by combining PA11 and flax or hemp yields for a more of a bio-based, easier recyclable or end-of-life type material combination. So let's talk about the supply chain of commingled fibers. So on the lower left, we start with input fibers, and from there, Concordia takes them and we commingle them. And so our commingling process, our finished product can be used directly into pultrusion or additive manufacturing, tailored fiber placement to make preforms, or filament winding. The next big grouping that our materials flow into is textile conversion processes like braiding, weaving, knitting, non-crimp fabrics, and those can be used in both 2D and 3D formats. And then from there, all of this gets consolidated, and might go into an organo sheet or might go into a 3D molded product directly. And then from there, all of these products can maybe yield a finished product, or maybe they get over molded into maybe in partnership with injection molding. And to me, the really interesting thing with a lot of this is, for some reason, a part isn't perfect. A part can be just remolded or reshaped. And of course, the whole recyclability of thermoplastics is phenomenal. All the products that I'm talking to you about today can be easily recycled, and just by chopping them up and injection molded them as an example, or maybe adding a little more resin content, because typically these have higher resin contents than injection molding. So lastly, I want to talk about material properties. And here we depict some testing for flexural strength of a carbon fiber PEI combination of a unidirectional. And the first thing you can see, it's a fairly linear, consistent elastic zone on the left-hand side of the curve, and then a little bit more noise on the end of the curves, or maybe there's some secondary type failures taking place before the full failure. But essentially, if you want to, there's really too many combinations of thermoplastic and fibers and volume fractions and so forth to be presenting numbers up here, but I'd like to look at the overview by, let's say, looking at the tensile properties and the rule of mixtures. Something like the rule of mixtures does a really good job predicting the properties of the tensile modulus. And with all composites, it's not as easy to come up with the tensile strength, but it does work pretty well. And then for compression properties, it's really a blend of the rule of mixtures and resin modulus. If you end up using low performing resins, it's going to be not as good as using high performing resins. And then lastly, the short beam shear test is always a good test to evaluate the interface between the fiber and the matrix. So in general, thermoplastic based composites are going to yield high performance mechanical properties, just like the thermosets. But in general, the impact properties of thermoplastic based composites are always going to exceed thermosets. So that's what I have for today. I look forward to answering any questions.
Thanks, Sean. We do have one question in here that's come in, and I'll encourage people to continue to put questions in the chat. And Sean, when if you see them pop up, go ahead and respond to those. Just make sure you put the two response line to everyone, not just hosts and panelists.
Okay.
But the question is, in your experience, which fiber volume gives the optimum properties of downstream pultrusion components?
So for pultruded components, it can it really varies. So I used to work in pultrusion for 15 years, and so every material format feeding into a pultrusion line is going to want to compact or consolidate at a different fiber volume. Say if it's a woven or braided or a unidirectional, or
let's
some
just say
sort of
unidirectional in this case. If you just say
so unidirectional. Yeah, like 60% fiber volume. In the upper 50s to low 60s is typically where it works well. There's no fillers in commingled fiber, so unlike thermosets. But as a rule of thumb, 58 to 60 is a real sort of happy spot for it.
Good. And one more question, then we'll need to move on. Is there a limit to the number of fiber types? For example, could you do a carbon glass peak hybrid? Is that possible?
Yeah, no, we've combined multiple fiber types. And so every fiber type has their own advantages and disadvantages. So for example, I mentioned flax and hemp. And so flax and hemp are made with short fibers or staple fibers. And clearly, you're not going to open those up like you would a continuous fiber. Otherwise, they would just fall apart. So there's some limitations from that perspective that sometimes affect us. But often we'll combine three types. Sometimes there's metallic fibers included as well. So for more functional fiber type paths down the road. So
okay, there's one more question I'd appreciate if you go answer it online. Go to the chat and answer it about you have suppliers of natural fibers in low twist formats. So sounds like somebody may be able to offer you something that might open up better. Who knows? So yeah. I'll let you answer that one. Thank you, Sean. And for the interest of time, we'll move on to our next presenter.
So, thank you.
Thank you. So our next presenter, we start with Professor Uday Vaidya, or CTO of IACMI. Uday, you want to see if you can go ahead and share?
Sure, Dale. Can you see my screen?
Okay. I can see it. Just put it in slide mode. Should be able to go.
Yeah, sorry.
Yep, good to go.
Okay, great. Thank you, Dale. Thank you, everyone. Good afternoon, and appreciate you joining this Innovation Insights that's very successful for several months and years now. So today I'm going to kind of talk a little bit different from the standard IACMI project. This is called as the NSF, which stands for National Science Foundation, Industry University Cooperative Research Center. It's a mouthful, but called IUCRC. Just to put it into context, you all would probably know that NSF is a basic science agency which funds TRL 1 to 3 work. There is a special division of NSF called the Industrial Innovation and Partnerships, IIP, which very much focuses on applied work, which is very unique to NSF. So this program, IUCRC, sits in the IIP division of NSF. Essentially, the model of this program is NSF wants to proliferate industrial collaborations with academic institutions, and it's a highly competitive and sought after program. We have only 48 in the entire country, such centers, and we are fortunate to be one of them. The basic center that is titled CHMI, Composites Hybrid Materials Interfacing. It's a glorious way of saying dissimilar joining or multi-material joining. Our consortium is led by Georgia Tech, and it has 2 site institutions, University of Tennessee and Oakland University in Detroit. So Georgia Tech leads as the lead site, Tennessee is the sister site, and Oakland is a sister site. Essentially, the way this works is all the sites have equal contribution from NSF. NSF puts in basically 150K per year per site. So 450K is NSF funding that goes towards the consortium on an annual basis. And that has to be matched by industry match in terms of this equal amount. So it's a 1-to-1 cost share. So for example, if Georgia Tech got 150K from NSF, it could basically bring in, say, 5 partners at 30K each to make up the 150K. So each center or each site is supposed to raise equal to NSF contributions. So it's about 900K per year for 5 years. So close to a $5 million program focused on industry problems that relate to joining, assembly, and essentially using the know-how of the PIs and the extensive assets and infrastructure to solve industry problems. So that's, I just wanted to give you some background on that. This particular center looks at holistic problems from design, conceptualization, all the way to prototyping and development. My colleagues at Georgia Tech, it's led by Chuck Zhang, who many of you know, he's the center director. His colleague, or our colleague in the center, Donghang Yao, is joining us today. And Dr. Syed Nasser is the Oakland PI, extensive work in fastening and joining over the years. And he is also joining us today, along with the staff colleagues on this center. So please feel free to ask us any questions you may have. So the key points, don't want to make this a long presentation, but like I said, there's a critical need for dissimilar joining and multi-materials in the industry today, and that is a given, whether it's for composite to metals or composites to ceramics or metals to metals, mostly polymer thermoset to thermoplastics. So essentially joining is a fairly diverse problem. This center is looking at essentially such projects which would help us advance that needle. And I'd mentioned the 3 university partners on this. The basic rationale is generally like this, that Georgia Tech has a lot of aerospace focus around its location, like Delta Airlines and surrounding suppliers. UT has IACMI, the automotive and energy focus, of course, and all the network represented here. And Oakland has a lot of potential collaborations with ground vehicles, as well as the GM headquarters, and the automotive hub is in next to them. So that's kind of catering to a number of sectors of the industry. I won't beleaguer this, but I want to mention that this effort has been in the making since 2018. We are supposed to submit a preliminary planning grant, which we were turned on for the first time. The second time around, we were actually successful, which led to a full proposal in 2019, which has now led us to 3 years of this program. We are now in the year 4 of the first 5 years, and it's renewable for another 5. Some IUCRCs have gone on to 15 plus years. Like you may be familiar, the Wind Star is one very popular one in the wind sector, for example. and many such which relate to our industries. Like I said, joining is an issue across the board. These are some very real examples of things we are working on, everything from vehicles to wind energy to mass transit, porting, infrastructure, energy distribution. So every one of these has issues and technical problems that tie to joining and assembly, design, NDE, all the aspects that go into this kind of technical needs. Today, this is a slide that Dale had put together a few years ago. If you look at the overall automotive alone, just this is an example from a BMW application using RTM and wet laid up parts. There are almost 50 plus parts here that itself required joining and assembly of some sort. So these are a lot of fundamental problems that need to be addressed, taking it then from TRL 1 to 3 to 4 to 7. The center, like I said, has several sub-topics that it is looking at, and you will have these slides at your disposal for reviewing and asking us any questions that may be specific ones to your needs or interests. Like I said, the three site PIs are the Chuck Zhang, Dr. Nasser, and myself. The IAB, which is the Industry Advisory Board, is made up of all the members of the consortium. For example, a full member here is, I'll go into the membership in a minute, but the IAB or Industry Advisory Board is an automatic vote once the member joins the IUCRC. In our case, the chair of the IAB is Nathan Schulz from Delta Airlines, and co-chair is Jessica Wallach from Sensco. It used to be Solvay. So they give us a lot of input and feedback and directions along with the entire IAB makeup here. At each site, we have faculty participating in this. I've just listed the faculty. I won't read each of their names, but in the Georgia Tech, of course, Chuck leads the center. Saeed is supported with Richard Liang, who's an expert at NDE, and other colleagues. At Dayakar Penamadu, who many of you know, works closely with our center. He is a co-PI of this center. And also colleagues from Oak Ridge, Ahmad Hassan, and others are part of it. So you, again, welcome to review the people and their backgrounds, and happy to provide any input you may have there. The membership structure of the center, a full member is $33K per year. Its annual renewal is not like companies tied to it for a full 5 years or anything, but if you see value in it, it's a renewable thing. This number, I'm clearly not a salesman, as you can tell, but this number is much lower than some of the other IUCRCs, which is a minimum of 50K. So if you're part of other IUCRCs, you could certainly compare and contrast us. What does that give you? Of course, it gives you the seat on the IAB to vote on projects. You can define and come up and guide on the technology roadmaps. You have access to pre-competitive and cutting-edge technologies and IPs, as well as interacting with potential employees, because the students on this project become directly affiliated with your projects. And then there's access to R&D across all the sites that I mentioned, including networking opportunities. So several times I've been asked, how is this different from IACMI? Certainly, IACMI also is a member of the CHMI. While IACMI operates at 4 to 7 with clear goals of the industry-led projects, a lot of the basic work gets done in the consortium such as this, and in an area that actually feeds into bigger problems that IACMI would take up in some of their efforts. So it's a very synergistic relationship and not a competitive one at all. Current members listing is here. Again, you might, obviously, all the names are well known, but for example, federal labs such as Air Force Research Lab, as well as the Army Research Lab and people like that are also very much participating in the consortium, along with companies, like I said, Delta and Dominion Energy, also small businesses like Endeavor Composites, like a startup which some of you are familiar with, Lockheed Martin is a member, Hexcel is a member, and so on. So you can review this list. IACMI has, in the first 2 years, has had 2 memberships, and right now they are a single member, but very much a very active one. There's several in the hopper, which you can see on the right side. This list is not fully updated, but DB Technologies, for example, is now a full member, and Oak Ridge has already committed. Muscle Polymer is also a full member. So some of these are very much, there's an ebb and flow of memberships, but I feel we have a healthy list of industry partners. These are a list of current projects. I won't read them, but I'll mention that there are these are all voted by the IAB. They have listened to every single pitch, including projects that IAB also pitches on their own. Like next week, or rather this week, sorry, just in the next 3 days, we have the meeting of at Detroit for the voting on the next set of projects, where IAB provided their inputs. So we'll be pitching like 9 projects, out of which I think, I'm not sure how many they will select. But there are projects that look at the durability of joints. There are projects that look at kissing debonds, for example, and evaluation, looking at, in our case, low-cost approaches to producing multi-material SMC with other overmolded constituents, embedded fiber optic sensors, and so on. So again, this summary of these projects would be available if you're interested. Some of the detailed IP information would be protected, of course. Dale, I think I prefer to stop here. I've given an example of a project. If somebody wants to know what a project looks like, these slides are there for your review. But I'll stop here and see if anybody has any clarifying questions.
Okay. So I don't know if folks have questions. I'd like to just comment myself from having been in industry my whole career is, I think there's a couple of real advantages for companies to become part of this. One is of course, the seat on the IAB and the ability to derive what research happens. Obviously the universities have ideas and bring those forward, but, the industry actually comes forward and says, hey, these are the things, problems we really want to solve. And if you want to create a project around that problem, please do, or we'll write a project around that problem. And then the other thing I think is very attractive about the IUCRC model is the overhead rate is limited to 10% on top of the costs. The third thing I would say also is that all of the IAB funds go to funding the students and their work, and not to paying the overheads or how the programs run. The NSF funds are used to operate the centers, and then all of the industry money is leveraged multiple fold to get the results. So you can easily get tenfold return on your investment. Get $300,000 worth of research for $33,000 if you join up. So that's the kind of thing I'd encourage, and obviously folks can reach out to you. They can reach out to me. I know you've got more slides in here. This deck, we'll be happy to make the whole deck available to them.
No, thanks, Dale. That's a very valuable point you made on the overhead costs. I would also like to invite Dr. Nasser and Dongang to make their comments. Saeed, do you have anything to add? I missed a bunch, obviously.
So, Saeed, I see a thumbs up. You're muted, but okay. All right.
Dongang, do you have anything?
I just want to thank all of you for joining us.
Yeah,
okay, go ahead, Saeed.
Yeah, I concur with my colleague Uday here. He's covered it very well. And Dale also, the follow-up was very helpful. And I will echo some of what Dale just mentioned, that the feds are limiting the indirect cost to only 10% that the universities can charge. So basically, it almost doubles the project budget in terms of what work you can accomplish from. And it mainly sponsors student stipends and things like that. No major personnel cost. I'm talking about the membership money. The increment from NSF is restricted to use for managing the sites. So it doesn't go into research. So that's why the board has a stake in the, has their basically skin in the game in terms of the return on investment for the membership fee they pay.
Right.
So,
Okay.
so
Great
with
point,
that,
sir.
I will be happy to take some questions. My colleague from Georgia Tech, maybe you want to add a couple of more statements as well.
I think this is Dong Yao from Georgia Tech. You guys did a wonderful job in explaining and also discussing the benefits of the center. I just want to add one more point. Also interns, if our students go into your company for intern, NSF are going to be covering the cost.
Yep.
Yeah, thank you.
Okay, thanks. Well, thank you all, gentlemen. And if folks have some other questions, please put them in the chat and we'll make sure they get answered here. So when you move on to our third presentation of the day, Scott Francis, who's the editor-in-chief of Composites World Magazine. And you know, I'm really looking forward to being in Charleston in October, not only for the Low Country food, but for the great event that this has become over the years, and you know, one that I find very, very interesting, very intimate, and quite productive. So, Scott, I'll turn it over to you, and if you want to share your screen.
Just a quick second. You guys see my
Yeah, do just put it in the slideshow,
presentation?
start the slideshow, and
All right.
there you go. You're good to go.
All right. Thanks so much, Dale. And thank you, IACMI, for the opportunity to speak to you today. Really appreciate your time. Just a quick overview about Composites World, if you don't know who we are. We're the business-to-business trade publication that serves the composites manufacturing industry. Our content is focused on the materials, design, tooling, fabrication, finishing of fiber-reinforced composite parts and structures. We have a printed magazine, newsletters, website, podcasts, webinars, and video. So we're, you know, trying to put things out there in the ways that make the most sense for how you'll use them. I have a very talented team that we work with. You guys know Jeff Sloan, perhaps, our publisher and brand VP now. I'm the editor-in-chief. Many of you know Ginger Gardner and Hannah and Grace. Just a shout out to all these talented people that kind of make what we do happen. So if you see us, they're all very friendly people. So hopefully when we see you, we'll see you in Charleston and you can say hi to some of us. Today's presentation, I'm going to go through a few things related to carbon fiber, which obviously the conference itself is dedicated to this material and the things that are occurring in the carbon fiber market. We'll go through a little bit about the traditional value proposition of carbon fiber and recent history and things that are happening in the state of carbon fiber today, challenges and opportunities with sustainability, new markets, a look at some of the things that are going on with trying to further industrialize carbon fiber, and just a quick overview of the agenda itself for the conference. So traditionally, carbon fiber, the big thing is low weight. That's always kind of been what we built this industry on. The low weight allows us to, has traditionally allowed us to come into existing applications that may have used some other traditional material and offer an alternative that could further offer fuel efficiency or longer product life, just various reasons to switch from a traditional material to one of a lower weight that had many of the same properties or even better properties. Here's a bit of illustrating that through recent history. Obviously, composites was a displacer of legacy materials, and everyone's heard of black aluminum, where this material has been used to replace metals. Throughout the 2000s in aerospace, we begin to hit some milestones with the 787 and the A350 as the first widespread use in aerostructures. And then obviously a lot of work in the defense side. And again, that was kind of seeing carbon fiber come in as a replacement material for existing materials such as aluminum that were traditionally used. As things kind of progressed, we started to see more applications where carbon fiber and composites were looked to as an original material for the applications, such as in the wind blade industry. So the current state of carbon fiber, aerospace remains the most valuable end market. Wind is the largest volume market. And, when we look to some of the applications, you see some of them listed here, a lot of aerospace applications, and increasingly more interest in automotive. That's always been a market that we were eager to get into. And I would say that we're seeing interest driven by battery enclosures and EVs, and uses there seem to be kind of ramping up a bit more automotive interest, which is I think we'll all agree is a good thing. And of course, some other applications, sporting goods, and oil and gas industry, race cars. But the thing about the aerospace is there's no current new program, and the status quo seems to be kind of where we're holding. So everyone's waiting to see what will be the next big aerospace announcement. Obviously, as we kind of look for that and look to increases in some of these markets, the other challenge that we have is sustainability. Composites have always been an enabler of sustainable, environmentally sustainable applications. They've been a great enabler of those sort of things. But as we look to sustainability as a topic within regulatory bodies and so forth, there's increasing scrutiny of supply chains, of the manufacturing processes themselves. So that has become a renewed focus and a renewed challenge for us. So sustainability, decarbonization, life cycle analysis, those are big topics that we all hear talked about. In the meantime, we've got new markets that are demanding these materials coming on the scene. So we have hydrogen is a growing market. The advanced air mobility space is one that we're all watching and seeing a lot of exciting things happening there with all of the prototypes and the different testing of vehicles that are becoming more viable in that space. And also the new space applications within private companies that have entered in the space race. And of course, still seeing interest in wind energy and other renewable energies. So carbon fiber has become an enabler for those markets, and it's no longer just an alternative, but a lot of times it's the only material option that can enable those applications and allow them to exist. Wind energy is a good example of that. Advanced air mobility is another good example of that. So with all of these different trends in the market happening, the need for new processes that are more sustainable, the looking at the volume that may be needed for some of these new markets as they're emerging, we really have to refocus on the industrialization of carbon fiber. And that's not easy. It has its challenges. It's a highly specialized material with a lot of barriers to entry for folks that are trying to either expand their capacity or start fresh. So there's a need for a lot more automation, a lot of process control, things to really allow to ramp up the production of the material to meet these needs that we're seeing. There's also other factors in the market, including surplus of carbon fiber entering from other markets, such as carbon fiber from China. That is a topic that has been of a lot of interest of late, people watching to see what is happening in the Chinese carbon fiber market. The country typically has the largest capacity, and it's growing quite a bit. At the same time, their domestic use of the material, their domestic demand has declined. So there's surplus fiber, and the big question is, what does that mean for the overall carbon fiber market? And that's an exciting presentation that we're excited to have at this year's conference. We will have a presentation by Lin Gang at our pre-conference session. He's of ATA Industrial Group. So hopefully that will give us some really great insights into the carbon fiber manufacturing capacity in China. We'll also that day be looking at the global supply and demand of carbon fiber with a presentation by Miriam Yagubi. She's presented for us before, and that'll be a great presentation as well. On October 9th, we will be looking at several topics. We'll have a keynote on carbon fiber and aerostructures by Richard Apps of Counterpoint Marketing Intelligence, as well as presentations on automotive, pressure vessels, fiber sizing innovations, and we'll have a special afternoon roundtable discussions. Those are going to be brainstorming sessions that are led by moderators. Dale's actually volunteered to be one of those moderators, so thank you so much for that, Dale. And that'll just be a really exciting time for some idea generation. We'll take a look at some of the things that come out of those roundtable discussions and share those ideas at the conference on stage. And then on the October the 10th, we will touch on wind energy, as well as electronics, sustainability, which we talked about, and life cycle analysis of the materials, and also a panel discussion on a hydrogen storage and that emerging market. So lots of great things in store. That is where I'm at. So any questions?
Scott, what's I know you've got a lot of other activities. You've got a couple of receptions that occur with this, a lot of networking that happens as well. But do you if you think about who typically attends, who you expect to attend, is there some particular breakdown around OEMs versus fiber producers versus intermediates producers?
Yeah, that's a great question. You can go to carbonfiberevent.com/attend. And that page offers a really great breakdown of some of the folks that we have. So typically, we get more than 80% of the attendees have a C-suite or management engineer R&D type of job title. The breakdown here is sort of around 24% are at the owner, president, CEO level, 25% are managers, 16% are engineers, 16% are R&D. So you get a lot of good FaceTime with those kind of attendees.
Okay, that's it. Kim has put the link in the chat for those who might be interested to register. Registration is not closed. Are there still hotel rooms available?
Great.
I was going to ask you, do you know if there's still hotel space available?
Oh, sorry. I'm not sure about that.
Okay.
If
If
anyone,
not, there are other hotels in Charleston. It's a great place to visit.
yeah, I'm not sure about the current status of the hotel, but yeah.
Yeah, so there's one question here, and we're nearing the end of the hour, but what's the current annual volume in metric tons per year, say, of production, and then how much of that is chopped versus continuous? I would imagine a relatively small portion is sold as chopped. But
I'm not sure if I've got that information at my fingertips at the moment, but we will be touching on it at the conference itself. So on the pre-con day, we will be breaking down the supply and demand. Miriam Yagubi of Future Materials Group will be discussing some of that. So I'm sure there'll be some good up-to-date information during that presentation.
okay, all right. Thank you very much. And
Awesome.
with that, we're near the top of the hour, and so it concludes another episode of Innovation Insights for September. So wish all of you a productive week this week, and continue well wishes through the end of 2024. Hopefully we'll see most of you join us again next month on October 21st for our next episode. So thank you very much, and goodbye.
Thanks so much for having me.
Thank you. Bye-bye.
Thank you.